Hello all and welcome to my YouTube channel. Welcome to the series where we are learning a agentic RAG framework implementation. So this is the part 2 of this particular series. In the part 1 we have already covered the basics of RAG operation, and also we have seen how exactly the RAG is different than the agentic RAG. So that difference we have already covered, and we have gained a thorough understanding how exactly these agentic RAG application works and what are the different types of agentic RAG and the basic RAG operations. Everything we have covered end to end in last particular video. So if you are interested in that, please go ahead and check out that video. The link is available in the description below. So let me give you the quick glimpse what we have covered, and that way we'll be able to build this story and we'll be able to move forward. Okay, so this is our YouTube channel, iTech. Please go ahead and subscribe to the YouTube channel. This is the part 1 of this particular series. So you can see we have covered the basics of RAG versus agentic RAG, and also we have explained a research paper, and we have gained a thorough understanding how exactly the agentic RAG evolved. And if you see, we have also covered the different types of basic RAG operations or traditional RAG operation. And then after that, we have done some practical implementation. We have tested how semantic similarity works. And then we have started with the agentic RAG application. So in the agentic RAG application, first we studied the single agent agentic RAG router, and this is what exactly we are going to see in this particular today's video, the practical implementation of single agent agentic RAG router. And also then we have covered the multi-agent RAG as well. So you can see multi-agent agentic RAG system. So this I would like to cover in the next upcoming video. So yeah, please go through this particular video. This will help you gain a thorough understanding how exactly the agentic RAG system works. So let's jump to today's part. So as I mentioned, we'll be implementing a single agent agentic RAG framework. So for this particular one, we have created a simple use case. This is a real-time use case that I have picked, and I have tried to build a story so that it becomes very easy for you to understand this. So if you see, let's say we have a, now just to give you the quick understanding why exactly we go for agentic RAG and not the traditional RAG. Let's say you have multiple vector stores, and then you want to connect those vector stores to your AI application. What happens is that with the traditional AI system, it is static system. You cannot connect to the multiple vector stores or multiple data sources that are available with you. And that's where the agentic RAG evolved, where we can connect to multiple vector stores or multiple knowledge base and that too with the help of agents. And now the agents are responsible to extract the information from the relevant vector store. So the today's use case is related to the e-commerce business. For example, in e-commerce, we have three different vector stores, or let's say we have three different data sources. First one we have is the product information, which is available in this particular product CSV. It can be anything. It can be CSV, it can be database. Second, we have order level information, which is there in order CSV. And third, we have the support CSV, where we have captured the support question answers. So as you can see, these three data sources are completely different. In products, we are capturing all the product level information, like the product details, the dimension of the product, the price of the product, all that information, the description is captured in the product database. Then second, we have orders information. In orders, we have captured the order level detail, like what's the order ID, who ordered that particular product, when it was ordered, what is the delivery status. All that information we have captured in order CSV, and I'll go ahead and show you that data sets as well. Then third we have is the support CSV, where we have captured the question answer related information, meaning let's say if users are asking any question related to the cancellation policy or any right related to the return policy, then those question answers we have captured in the support CSV. So that's how we have three different data sources. Now, what happens with traditional RAG, if you embed all these three into a single vector store, what will happen is that whenever you are performing a query operation, meaning, right, like whenever user is hitting any query with normal RAG operation, what happens is that the first query goes to the vector store. And from vector store, it fetches the top K records. It can be top 2, 5, 10, whatever it may be. And then it passes that to the large language model. And then large language model generates the final response based on the context that is extracted from the vector store. So in this case, if the user is asking question related to the order CSV, what will happen is that As you have combined all these details into a single vector store, your top K record may extract details from product information instead of order. And in that case, that information will be passed to LLM and your LLM will generate a false response. So in order to avoid that, it's better to, or it's always recommended to capture these different data sources into different vector store. And then based on the user query, you can route it to the correct data source or correct vector store. And that is what the task of agent is going to perform in this particular use case. So you can see we have a user. So this user is asking a query. That query first goes to this particular agentic framework. And this agentic framework is then responsible to route the query to respective data sources. But before hitting this particular query, we need to perform an embedding operation. So all these three CSVs, we are passing it to the embedding model, and we have used open source model for embedding as well as for the uh, building this AI application. So you no need to worry about that. You will be able to quickly build this application without spending a rupee, right? Or without spending any money. So this embedding model, we have used the SentTransformer. There is a model that we have used from Hugging Face, which is open source, in order to embed this data. So these three data sources we have embedded. That embedding we have stored into three different vector stores. So first we have stored it into a product database. This product CSV goes to product database. Order CSV, we have stored it into the order database, and support CSV, we have stored it into the support database. Now these three are the vector stores, meaning we have captured these data sources in the form of embedding and the indexing. Now, whenever user asks this particular query, first the RAG router agent, which is a Gemini LLM based model, meaning we have used large language model from Gemini. We'll again show you how exactly we can use that practically. And that particular model is going to give this generative AI capability for our RAG router agent. We have passed a prompt for this particular RAG router agent, and this prompt is going to, based on the user query, divert these or route these query to these respective databases. So whenever this query goes to, let's say, based on user question, RAG router decided that, okay, we need to extract the information from product CSV, then it will route it to the product DB. If it's related to the support, it will route it to the support DB. And then from there, it will extract the details. For example, let's say if user is asking question, who order a wireless mouse? For example, that's the question. So this router agent will understand that, okay, wireless mouse is a product, right? So user is asking about product information. So it will go ahead and hit the query to this particular product DB. And from there, it will pick the top, let's say, two records, which are matching with respect to the wireless mouse from this particular DB, and it will give it to the RAG router agent. And then RAG router agent is going to generate the final response, and that final response will be handed over to the user. So that's how you have increased your accuracy of retrieval, right? RAG is retrieval augmented generation. So that's how you have improved your accuracy of RAG operation, and that's how the single agent is going to handle this. Now in this video, we are focusing on the single agent. In the next video, we'll see for each database, we can have different individual agent. That is again going to improve your accuracy. Here your single agent may confuse for some of the user questions, and it may make mistakes whenever it is routing these queries. But let's see, as these RAGs are, as this router agent is a LLM powered agent, it is going to handle these queries very efficiently. So I hope this use case is clear to you. It is very simple. User is going to ask questions related to the product, related to the orders or support information. Then RAG router agent is going to route that query to the respective vector store. From there, it will pick the top search records or top match records with the help of semantic similarity, and then it will pass that response to the RAG router agent, and RAG router agent is then going to generate the final response. So this way you can build this particular system in order to answer or in order to extract the information from your custom vector stores or the databases. Later on, you can replace, let's say, orders DB from vector store. You may use some APIs here. And from that API, you can hit to your custom external sources. It can be your website, it can be anything, right? It can be your external data sources. From there, you can get that particular information. So this use case has a wide range of applications. You can just, with simple modifications, you can build a high-end applications. With the help of this simple architecture, you can go ahead and build a wide variety of different projects. So without wasting time, let's jump into the coding part. Okay, so we will be using a Jupyter notebook or Jupyter lab in order to complete our coding session. So first of all, if you haven't installed the Anaconda, go ahead and install the Anaconda Navigator in your desktop. And then once the Anaconda is installed, go ahead and open the Anaconda prompt and then just go ahead and create a Conda environment, or you can create any virtual environment as well. With the help of this simple command conda create -n rag, you can go ahead and quickly create the virtual environment. Make sure you are using the latest Python version. So you can select yes. This will pick the latest Python. I have Python 3.13 installed. So let's go ahead and quickly activate the environment. Conda activate rag. Okay, and let me show you the Python version. You can see I am on Python 3.13. You can also go ahead and use the latest Python version. Now quickly let's go ahead and install the Jupyter. Pip install Jupyter. This will install the Jupyter notebook and Jupyter lab eventually. And then we'll be using that particular Jupyter lab to perform our coding session. So the RAG environment is activated. So let's switch to the respective directory. I'm going to switch to my directory. This is my directory, Agentic RAG, and then let's type Jupyter lab. This will open a Jupyter lab session for us to continue our coding. Okay, you can see it has created this. So let's go ahead and create new notebook. You can select Python 3 notebook. Let's give name as Agentic RAG, and let me quickly go ahead and copy the dataset. Okay, so I have copied these three CSVs. Let me go ahead and increase the font. So let me quickly show you. As I mentioned, we have these three data sources: catalog CSV, which holds the product information, order CSV, and support KB CSV. So let me show you what is there in these three data sources. So you can see we have product level information like product ID, product name, product description, and the price information for each product. So we have a couple of good examples to continue. And you can see all that information, and you can see the products are related to the gaming, related to the mouse, keyboard, USB, smartphone, Bluetooth speaker. All that information we have captured along with their description. Then second CSV we have is order CSV, where we have captured the order level information. You can see order ID, the name of the user, the product name that particular user order, the status, the delivery status, and the date on which that order was placed. And again, this is the dummy data that I have prepared. Then we have support knowledge base, where we have captured the frequently asked questions and their respective answers. So as you can see, users are asking question like, okay, how do I return a product? And then we have captured, you can return a product within 30 days, like question answer, the most frequently asked questions you can see, and the fact ID, frequently asked question ID. So that's the three sources that we have seen. So as you can see here, product CSV, order CSV, support CSV, we have already captured. So let's go ahead and start writing our code. First of all, we'll have to install the necessary dependency. So let me go ahead and add this. So we'll be using OpenAI is not required. So let me remove that. We'll be using ChromaDB in order to create the vector store. You no need to create any accounts as such. We'll be creating a virtual vector store, and I'll show you how exactly we can do that. Then we'll be using pandas to read these CSVs. Then Crew AI is the open source agentic framework which is available, and with the help of which we can quickly build the agentic application. So Crew AI is the most easiest framework that is available out there in the market, with the help of which we can quickly, by writing a minimum lines of code, we can go ahead and build the agentic AI application. So it's for that purpose. SentTransformer is in order to download the embedding model. Uh, so with the help of this SentTransformer, we'll be tokenize the details that are available in these three catalogs, and then we will be embedding them and storing them into the ChromaDB. So let's quickly go ahead and install these three dependencies. So okay, you can see the dependencies are already satisfied. Okay, so let's quickly go ahead and import the necessary dependencies. So again, all these three we have already covered. From SentTransformer, we'll be importing the SentTransformer class, which will help us to load the embedding model. So let's see if there are any issues. We'll go ahead and install the dependencies again. Okay, we are able to load all the dependencies. Now let's go ahead and read these three CSVs quickly. So with the help of pandas, pd.read CSV will be loading these three CSVs, and let me go ahead and quickly show you. So in the catalog DF, we have product information. You can see this is the information that we have seen: product name, description, price. And in the support, we have frequently asked questions. You can see question and this respective answer. So we have these three sources that we have loaded. Now, let's go ahead and quickly load the sentence transformer model in order to embed these data sets. So we'll be using a sentence transformer class and we'll be loading this particular model, MixBread AI, MXBAI, embed large V1. This is the model which is going to generate a embedding of 1536 dimension. So let's go ahead and quickly load the model. For you, this model loading will take a time. For me, it did not take much time because I have already loaded this particular model in my memory. Like the model size is close to 650 MB, I believe. So which will take a quite decent amount of time, maybe 3 to 5 minutes for you based on your internet speed. And again, you no need to sign into any website in order to load this model. So Sentence Transformer will take care of loading this particular model from the Hugging Face website. And now we have the embedded model available. So let's go ahead and create the vector store in order to build this particular embedding. So first of all, we'll go ahead and quickly write this particular function embed text, which is going to generate embedding for the given text using Sentence Transformer. And it is going to just return the embedding. So you can see embed.encode. We just need to pass the text that we are going to extract from the CSV, and we will be converting them into list, and that it is going to go ahead and do the embedding. So this is the function that we'll be using. Now let's go ahead and create the vector store first. So creating vector store with the help of ChromaDB is very easy. You can see ChromaDB.persistent client will be using path. We are giving this particular folder name Chroma multi-store. Persistent client is going to create vector store into your local system. Basically, it's a in-memory vector store it is going to create. So I'll show you how exactly it will look like. And that way you no need to actually go ahead and create the ChromaDB account and add your credentials in order to connect to that. You can do that. You can replace this vector store with any of vector store that you want later on. You may use Pinecone, StraDB, or Azure AI search. Whatever is your requirement, you can go ahead and replace this particular part. So for the simplicity purpose, we are going to use this particular simple ChromaDB. So as you can see, so once we execute that, you can see it has created this particular Chroma multi-store, a local instance. And if you see currently it has created chroma.sqlite3, meaning it is going to create whatever embedding it is going to create, it is going to store them into this Chroma SQLite. And the SQLite is a type of database which is going to help store your embeddings or vector data. So let's go back. So you can see we have created the client for ChromaDB. Now let's go ahead and create the collections. So we'll need three collections in order to create these three vector store. So creating collection is very simple. You can see first collection name we are giving catalog store. First collection we are giving name as catalog, and it is very simple. We just need to use Chroma client that we have created dot get or create collection, which is going to create this particular collection for us. Similarly, we need to create the collections for remaining two. You can see we are creating for support KB and orders. So now we have created these three collections. Now in these three collections, we need to go ahead and add our embedding data or store our embedding data. So let's quickly go ahead and do that. Okay, as a next step, we can go ahead and insert the embedding. So for inserting the embedding, we can just iterate through a catalog DF, first one, whatever product information that we have loaded with the help of iter rows. So iter rows is going to iterate the data frame one by one, row by row. And from there, we are going to pick the product name, description, and price. So, and in the catalog, if you can see, we have product ID, product name, description, price, out of which we are going to ignore the product ID because product ID is not required. So we have excluded that. So product name, description, and price, those three information, and we have converted that into the text. So let me quickly go ahead and show you how exactly it will look like. So if you see, for each row, we have captured the product name, hyphen, we have captured the description, and at the end, we have captured the price in the bracket. So this is how it has created this data, and now we'll be going ahead and embedding this data and storing it into the vector store. So for that, In order to add that, we'll be using catalog.add documents is the text. Against this text, we'll be adding a indexed ID, and for that indexed, we'll be performing a embedding. So the embedding text will be using embedding text function in order to embed this. In order to quickly show you how exactly this embedding looks like, so in the embedding text, if we pass this particular text, so it is going to return this embedding. You can see it has embedded this data. It has created a semantic vector for this particular sentence. And this model that we have used, the large V1 model, is going to create this embedding by preserving the semantic meaning of the text that we are passing. And it is going to create the embedding of size. So let's check what's the size of vector that it has stored. So let's print the length of this vector. So it is 1024. So that's the size, this size of vector it has created. And then we are going to add that particular, you can see this particular embed text is going to create this embedding that we are going to store into embeddings. Then we are going to assign a index. So whatever index that we are going to pass based on the rows, it is going to give that index name. And then the document text, this document, whatever is there, it is going to pass. So the data set is going to look like this text, then the index, and then the embedding. And that data we are going to store it into the vector store. So let's go ahead and quickly store that. And if you want, let me go ahead and print how exactly it is going to store that. So first it is going to store the text, then it is going to store IDX, and then the embedding. Okay, you can see first text, for that text, this is the index and then the vector. Then you can see the text, the index, and the vector. So this is how the data we are going to store it into the vector store. Okay, so this part is done. This is for catalog dev. Similarly, we'll have to go ahead and perform the vector embedding for remaining two. So let's go ahead and do that for remaining two as well. You can see again we are iterating from support df, and then we are going to store it into the support store that we have created. So you can see here we have created support store. Under that support store, we are going to dump this particular embedding. And similarly for orders df, we'll be going to create the vector store. So this will take some time. You can see it is going ahead and creating these embedding. You will not be able to view the data that is available. You can see under SQLite, it has created 3 folders. You will not be able to see this data, but it has created this in-cache vector store or local vector store. Okay, the vector store has been created. So this part is done. We have created these embedding and we have stored those embedding into these 3 vector store, Chroma vector store. So that part is done. Now the next part is we need to write the function in order to query the details. If whatever question that user is going to ask, based on that, we need to extract the details. So let's see how exactly we can go ahead and retrieve the information. So to retrieve the information, we can use the function. As here we have used add to add the document. Now we can use catalog store dot query to query, and in that we can pass the text that we want to extract. But that text we need to pass it in the form of embedding. So for that, again we can go ahead and create the embedding first. So you can see embed text will pass the query, and then will pass end results. End results is going to take care of extracting the top matching records. Let's say we are passing 3, and let's go ahead and pass query as well. So let's say this query is, for example, wireless mouse. If we are passing, so it should go ahead and extract the top 3 matching records from this particular catalog store. Okay, sorry, the bracket is missing. Okay, you can see it has extracted these 3 IDs, C0, C10, C17, and these are the documents it has extracted, 3 documents. You can see wireless mouse is the first response, second one wireless charger, wireless earbuds. So these are the 3 matching records that it has extracted from this particular catalog store. So our query is working. And then you can see the distances it has captured. This is basically, it is identifying how similar these vectors are. You can see first vector is 133.99 points, and you can see that distance is increasing, meaning it has identified the vector difference between these semantic vectors that we have created. And now this information we are going to feed it to the agent in order to generate the final response. But first of all, let's go ahead and create these embedding. So the code is very simple for creating these three search function. So you can see we have created search catalog, and same line we have added catalog store.query embedding we have passed query, which we will pass dynamically, and then end results equals to 3. Top 3 match records will pass. And then we are going to flatten these responses. So basically, out of this, we are going to pick only the document section. So if I show you this quickly, it is just going to extract the documents out of this. So this, let's go ahead and store it into result. You can see it has extracted top 3 match documents because that's what is required for us. We don't need to worry about the score as such. Whatever is these 3 responses, based on that user question was related to wireless mouse, so our agent is smart enough to pick the first response and ignore the remaining 2. Sometimes you may get this user question into second or third response, so our agents are smart enough to pick that particular response. So that part is done. Now similarly, we have written the function, and then it is going to return the flat results, and at the end we can see and also we have written the function for search support and the search order. Now why we have written these as a function? Because now our agent is going to call these functions. For our agent, we are going to add a custom tooling capability with the help of which it will go ahead and call these functions based on the user query dynamically. Now with this function, let's go ahead and test this now. So let's say if you want to test this, we can add search query, and we just need to pass the text. So let's say if I'm passing 4K monitor. Okay, you can see it has extracted the details which are matching to 4K monitor. All these 3 top match records it has extracted. So that's how these functions are going to work. This part is done now. The next part is if you want to search the another one, let's say if we can go ahead and call this particular search function, search support. From support, let's say if you want to identify how to return the order. You can see how do I return a product, how do I cancel my order, how do I track my order. It has extracted these top three matching records from that. Similarly, the search orders will work. Right now, let's go ahead and test that quickly. For search order, let's see if I'm asking question, who ordered wireless mouse? You can see order 5001 John Doe order wireless mouse, and which was delivered on this particular date. So that's how now these functions are going to act as our custom tools in order to extract the relevant information. That relevant information then will be parsed through the agents, and agent will generate the final response. But now the part is how exactly you are going to call these functions, because if user is seeing 4K monitor related information, then our agent should divert or route that query to search catalog, right? If the query is related to the order information, it should route it to the search order. How that is going to happen? That's going to happen dynamically, and that's where the agentic capability that we are going to add. So for that, let's go ahead and import the necessary dependencies. As I mentioned, we'll be using a Crew AI. So from Crew AI, we are going to import agent in order to build the agent. Task, which is going to add task capability for our agent. Crew is nothing but the collection of agent. So in this case, we'll be building a single agent. We can see how exactly we can build that. LLM in order to add the LLM capability. And then from Crew AI, we'll be importing tools in order to register these tools. Whatever functions that we have created, we need to register them as a tools for our LLM so that it can call those tools as and when required. So let's go ahead and import that. Okay. So let's go ahead and load the large language model. So with the help of these simple functions, we'll be importing a large language model. So you can see you can add a Azure OpenAI or Gemini model or any your Grok API keys. Whatever is available with you, you can go ahead and add that. In order to keep it simple, or in order to make sure that we no need to spend a money in order to execute this project, I have used the open source large language model from Gemini. So you can see we have used this Gemini 2.0 flash model with the temperature 0.2 in order to handle the randomness, and the class LLM from Crew AI, which is going to create the LLM for us. Now, before consuming this model, you need to load the secret key for this particular model, because for using the Gemini model, you need to create a API key. So in order to create that, you can simply go ahead and just type Google Studio, and under Google Studio, you can quickly just log in with your Google account and you will be able to create API key. So you can see you have option available, get API key. You can click on that. and then create API key, which will create one API key for you. So you can create any API key and you can grab this particular API key and pass it to into your code. So that's how you can grab the API key. And in order to set the API key, so here we need to load that API key into the environment variable. So make sure you use this particular name, Gemini API key, then only this LLM class will pick that. And here you can pass your API key. I'm going to delete this particular API key later on. So make sure you are not sharing your API key with anyone. So let's see. Okay, LLM is successful now. We have loaded the Gemini 2.0 Flash model. Now let's go ahead and quickly create the router agent. So to create the agent, let's give name as RAG router, and then we can use a agent class that is available from CrewAI agent, and into that we can go ahead and pass few details. Like first of all, we need to pass the role. And if you are not familiar with the CrewAI, I would recommend go ahead and check out my playlist. I have already captured the CrewAI part as well. So under my YouTube channel, if you go into the playlist, you will find this particular playlist, CrewAI Masterclass. I will add that link in the description below. You can go ahead and check out that, as I have already captured how exactly we can build a multi-agent framework with the help of CrewAI. So go ahead and check out that. Then role, you can give RAG router agent. Along with that, we need to pass a goal and the backstory. So let me just add that. So simple goal we have added. Understand the user query, pick the right tool, run it, and refine the results into clear final answer. A simple goal for the agent. Then backstory, what exactly is that particular agent is. This is just like adding a system prompt, meaning giving specialized capability or adding specialized information for our agent so that agent can behave in that particular way. So you can see you are a RAG router agent, a single powerful agent that handles the entire RAG process. You decide which vector store to query, execute the retrieval, and review multiple results and return only the best refined answer. So that's the backstory that we have given, because single agent is going to identify which vector store we need to call. So that's how we have given that. And then simply we need to go ahead and pass the LLM capability. So LLM, we have already defined this particular LLM. So that's how we can go ahead and build the agent. Now, how exactly we are going to register these custom functions that we have written to this particular agent? So for that, we are going to use this tool class. So after this, we can go ahead and use tools. And for defining these tools, we need to pass the list of tools. But first of all, let's go ahead and create the list of tools. So in order to create the list of tools, we can use the decorator that is available under CrewAI. You can see with the help of this @tool, we just need to give the name of tool, search catalog, and we need to write this function. Let's say we have tool search catalog, where we are going to pass query, and then it is going to call this search catalog and query. Meaning whatever this search catalog that we have written, this function and the query we are calling inside this tool. You can see the function is calling the function, and under which we are passing this query. Now this is going to give feasibility for our agent to register them as a tools into the agent. Now agent knows what are the capabilities that it holds. It holds these three different tools. So similarly, we have registered the tool support, we have registered the tool search order. Similarly, whatever functions, custom functions that we have written, it is calling that. And you can write any custom functions here. And that way you can easily enable the tool functionality, custom tool functionality for your agent so that it can perform a customization task. And then here we just need to pass then these tools. Make sure you need to give this particular doc string, because agent is going to read this doc string, and accordingly agent knows what is the capability of this particular tool. So we just need to pass these three tools here. Let's pass comma separated these three tools. And with this, let's see what's the error. Okay, it is not defined. I forgot to execute that. And you can see our RAG router agent is ready. Now we just need to go ahead and kick off the agent. So with crew, starting the conversation is again very easy. As I mentioned, the syntax is very easy for Crew AI. We have just defined the RAG agent. We have registered the tools as well. Now we just need to kick off the conversation. But before that, we just need to give the task. So we need to assign this task for our agent. So let's go ahead and quickly create the task. So again, we can quickly go ahead and create this task. You can see we have used the task class available in Crew AI, and we need to pass the description. The user asks this particular user query, will pass this user query. And then we are giving step what exactly this agent needs to perform. Backstory is going to help with the system prompt, right? Like what is the backstory? What is the capability of that particular agent? Task is going to help what is the custom thing that it needs to perform and in which step it needs to perform. That we have given. You can see decide which tool to call, catalog support order, then execute that tool. The tool will return top 3 possible matches. You need to read and compare them carefully. Select the single most relevant response, rewrite it in natural human friendly response. Do not just list all the results. Do not return raw tool output. Only provide the final refined answer. I have added this particular task by going through multiple iterations in order to generate the final human readable possible or human friendly response. So accordingly, you will have to update this task based on your custom requirement. And then expected output, we have given a single concise natural language answer to the user's query, meaning we have added lot of custom rules for our agent. You can see so that it should not this is basically to control the hallucination of our large language model. So by adding these descriptions, backstory, goal, and expected output, now our agent is very robust to perform our custom task, and we have controlled the hallucination as well. And then agent, we need to pass the RAG router as the agent that we have created. So our task is also ready. Let's go ahead and quickly add this task into a function so that we'll be able to quickly run that. So let me replace it with this query runner. So I have just added this under a function run query where we are passing this user query, and this is the task that we created. And to kick off the crew, we can see first of all we need to go ahead and build the crew. So as I mentioned earlier, crew is nothing but the number of agents, right, that are coming together to perform a particular task. So in this case, we just have single agent. So in the list, we have given single agent. If you have multiple agents, you can go ahead and add a comma separated agents. So this is the agents that we have given, task we have defined, and verbose true in order to print the conversation that is happening. And with this, we are generating the crew output. Very easy, crew.kickoff. That's it. And it is going to kick off the conversation. And that is what we are going to return. Crew output.raw.strip, which is going to just strip the output and give the final response. But this verbose will help us understand how exactly the conversation is going to happen. So we are ready with all the things now. So starting from initial, right, we have read the CSV, then we have embedded the text, we have created the Chroma collection, then we have embedded these data into the vector store, then we have built a search query tool in order to query the records from vector store. Then later we have leveraged the Crew AI in order to build the agentic framework. Then we have used the Gemini 2.0 Flash model. We have registered the tools, and then we have built the agent, and we have given a task for that particular agent. So let's go ahead and test this particular function now. So we'll be using a simple code. Let's say we have passed this particular query, which product the Chris Johnson have ordered. Then we are going to call this run query function, and that run query function will go ahead and execute this, and then we'll return the final question and the final response. So let me show you the product order by Chris Johnson. So it should be there in orders database. So you can see Chris Johnson ordered a smartwatch, right? So the agent should go ahead and understand that, okay, it should call the orders CSV, it should call the orders vector store in order to get this information, because as the word product is available, it should not go ahead and call the orders or catalog vector store that we have created. So that is the task of our agent. Let's say whether it is working correctly or not. Now, the moment we will start this, you can see it has started the conversation. So first we can see crew execution started. This is the crew. It has created one ID in order to remember the conversation. Then first you can see agent started. It has called the RAG router agent. That's what we have defined. And then these are the tasks that we have given for our agent. And this is the task. The user asks which product the Chris Johnson have ordered. And these are the steps that it needs to follow. Then it has started the execution. You can see it has called search orders correctly. You can see the magic. It has not called the product vector store. It has called this particular search order tool. And then it has executed that, and you can see, okay, the user is asking question about the specific order. Therefore, I should use search order tool to find out the relevant information. How beautifully it is understanding which tool to call. It has called the search orders, and then this was the user query. You can see this is the result, the top 10, top 3 result. Order 5007, Chris Johnson orders smartwatch, which is going to process, which is under processing and will be delivered on 2208, that information. Then this is the second query and the third query. Now, out of these 3 responses that it has extracted, top 3 responses, it should pick the most relevant response. So in this case, the most relevant response is first. This is what we are asking Chris Johnson, what exactly it has ordered. So then you can see task execution is completed, and final answer that agent has generated is this. RAG router agent, the final answer, Chris Johnson orders smartwatch in order number 5007, which is currently processing as of 22/08/2024. And then task has completed. And finally the queue completed. That's how exactly the conversation have happened, and this is the final response that we are printing. For this particular question, final answer is Chris Johnson ordered smartwatch with this particular response. Meaning our agent is calling this particular, so whenever now this user query is coming, it is understanding which vector store to call. It has mentioned that call the orders DB. From orders DB, it has extracted top 3 records. Then out of those top 3 records, the agent is smart enough. It has extracted the final response, converted that final response in human friendly answer and given back to the user. So that's how we have built this very beautiful system, and I hope you understand how exactly the agentic RAG works behind. So let's go ahead and try a couple of other examples. So instead of this now, let's go ahead and see support DB. Let's pick one example. Okay, let's ask this question. How do I redeem a gift voucher? In order to add some complexity, let's remove this gift. How do I redeem voucher? How do I redeem a voucher? Let's see. Now let's see whether it is going to call the support KB or not. Again, you can see the conversation has started, queue execution started, RAG router agent, then it has called search support tool. You can see tool execution, it is calling the, you can see the user is asking about how to redeem a voucher, which is a customer support related question. So it is using tool search support. Then it has extracted these top 3 records. You can see how the semantic similarity is working very accurately. How do I redeem a gift voucher? And then the response. Now, based on that response, it is going to generate the final response. Enter your gift voucher code at checkout to redeem the balance. And the final response, you can see if user is asking how do I redeem a voucher, enter your gift voucher code at checkout to redeem the balance. So you can see enter your gift voucher code at checkout to redeem the balance. It's working accurately. Let's try one more from product information. So from product catalog, let's see. Okay, let's ask the question related to smart TV. Do we have smart TV related products? Let's see whether it is calling the correct information. So crew has started, agent started, search, nothing found on disk. Okay, nothing found on disk. I think we have forgot to execute this particular part. Let's go ahead and execute this part once again. Yeah, I think I forgot. You can see now it is going ahead and embedding that. It will take some time. Sorry, my bad. I think it was not able to capture this complete data sets from this catalog TF. Now it should go ahead and work. Let's go ahead and again execute this. View started. Then you can see it has extracted this particular search catalog tool, and then you can see related to the smart TV, it has extracted these 3 records, out of which smart TV is again available at first location. Then agent has generated the final response. Smart TV 50-inch 4K is available. And you can see, do we have smart TV related products? Final answer, smart TV 50-inch 4K Ultra HD smart TV with streaming apps, and the price is $449. How beautiful it is working, right? So I hope this was helpful for you and you gain a thorough understanding how exactly the agentic RAG operation works. So I'm going to drop the link for this particular code in the description below. Please go ahead and check out that and try running this particular project. You no need to spend any money. You no need to create any, you no need to add any card details as such. Everything is open source. You will be able to execute this particular project. And don't forget to try it out on your custom use cases that you are looking forward. So yeah, I hope this was helpful for you. And if you like this particular session, please go ahead and like the video, subscribe to my YouTube channel and share it with your friends. And if you are interested in learning more related to the RAG as well as related to the agentic AI, please go ahead and check out my YouTube channel. I have added a couple of playlists related to the AutoGen to build the agentic AI application, Crew AI, and there are many more. Please go ahead and check out that. Some of the links are available in the description below. Also, if you are interested in building the AI applications, the agentic AI applications on Azure, then I have covered those under my Udemy courses. So I have dropped those links in the comment section below. Please go ahead and check out that as well. Yeah, and I hope this was helpful for you. Stay tuned for the next part of this particular series where we are going to cover a multi-agentic RAG application. So thank you so much, and I'll see you soon in the next video. Thank you.